This lecture will be on the velocity transformations, the Lorentz velocity transformations. You remember when we did the Galilean transformations, remember they didn't have these gamma factors in there. When we took the derivative of it, we got the velocity transformations. We need to find out what the velocity transformations are for these Lorentz transformations. So what do we have? We have ux prime. That's what we want. And we know that's derivative of x prime with respect to t prime. Well, I can't just take the derivative of this because these aren't t primes. I would actually have to use the chain rule on it, but I'm going to do it a little differently right here. I'll just say, first of all, what is just dx prime? Dx prime. If I come to here and we just take the differential of it, this is all a constant, so that would just become a dx minus v dt over that. So this would just be dx minus v dt all over the square root of 1 minus v squared over c squared. And then I say, what is dt prime? Dt prime. Well, we can come right back to here and take the derivative of this too. The dt prime would just make that a dt, and they would just make that a dx. Everything else is constant. So that would just be dt minus dx v all over c squared divided by the square root of 1 minus v squared over c squared. So if I wanted to find ux prime, I can just divide these two because that's what it is. It's dx prime dt prime. So ux prime is equal to, now if we divide these two, the square root terms drop out. And so we just have dx minus v dt all over dt minus dx v over c squared. And then one last step, I'm going to divide both sides, top and bottom, by dt. I'll just multiply everything by 1 over dt, 1 over dt. I can do that. So we get ux prime is equal to, we're multiplying this through everything, dx dt, well that's ux, minus, these two cancel, minus v. Well, that's just what our Galilean transformation was before, but now we have this extra stuff in the denominator. This times this is 1, minus dx dt is ux, minus ux v all over c squared. So there is my velocity transformation. And you could see when v is small compared to c, this thing is pretty much gone, and you get our Galilean transformation. If we go reverse, we don't have to rederive it. Remember, we said you switch the primes with the unprimes and change the sign of the v. So that means ux is ux prime. This would be plus v all over. We change the sign of the v, so this one will be plus right here. So it's 1 plus ux prime v all over c squared. So there is going back the other way, right there. Well, that's the ux. Let's do the y now. We'll do it the same way. We'll say y prime is equal to dy prime dt prime. And we'll do exactly what we did before. What is dy prime? Well, y equals y prime, so dy prime equals dy. Okay. And the dt, we already did it. It's right here. So now, if we just divide these two, so this uy prime is equal to dy all over all of this, dt minus dx v over c squared. And then we have this square root term, which comes all the way back up to the top. Square root 1 minus v squared over c squared. And just like before when we divided top and bottom by dt, I'm going to do it over here too. So uy prime, if I divide this by dt, that is uy. Still have 1 minus v squared over c squared. If I divide this by dt, it's 1. Divide this by dt, it's ux. So this becomes minus ux v over c squared. So you can see that uy, what Mary sees in the y depends on what Frank sees in the x right here. So there is my uy prime, and then if we do it in reverse order, uy is just uy prime. We don't change the sign of that because v is squared. Square root 1 minus v squared over c squared. And then this stays the same right here because, oh, sorry, we're changing the sign of v, so that becomes a plus. 1 plus ux v over c squared. The z would be exactly like the y right here. I'm not going to do that right there. But okay, so there is our transformation for velocity. A little more complicated. Remember for this, when v is small, this is gone and that's gone, and you get uy prime equals uy, which is what we had before. Okay, so now that we have these here, let's just say, let's look at some examples right here. Suppose we have a rocket ship right here, traveling at some, well, actually, we'll just say up here, traveling at some velocity, let's say 0.7 c. And then he's traveling at 0.7 c, and he shoots out a missile out of the front end of him at a speed of 0.8 c relative to him. So relative to him, he's shooting it out. Is that object going faster than the speed of light right there? If this were Galilean transformation, you would just add it up and you'd say it's 1.5 c right there. So how do we work this problem out? We want to know is how fast do we see this rocket going at 0.7, and we see the person in the rocket shot something out of 0.8 c. What do we see this object being shot out at? That's what we want to answer. So, well, why don't we just say this is Mary. Mary's in here, right there. And so if this is just the speed of Mary, that's what v is. That's 0.7 c. And she's throwing something in the x direction, so Mary is ux prime. Remember, everything is prime that she sees, is 0.8 c. And we want to know what Frank sees, which is ux. That's what we want. Well, we just come over to here. It looks like we just plug it right into here. We get ux prime plus v, so we just get ux prime plus v all over 1 plus ux prime v over c squared. So ux is equal to, well, we add them up in the numerator. That's the 1.5 c. That's what we would have had with Galilean transformation. But now we have this denominator, which is 1 plus 0.8 c times 0.7 c, which is 0.56 c squared. 0.56 c squared over c squared, which is 1.5 c over 1.56, which is less than the speed of light because the denominator is bigger than the numerator. If you plug this in, this ux is equal to 0.96, 0.96 c right here. So, well, suppose she shot it out a little bit faster. How about if she shot out light? So what would happen if we were to replace this, instead of shooting it out at 0.8 c, let's shoot it out at c, the speed of light. And she's moving at 0.7 c. How fast does Frank see it go at? Well, the only thing I would do is I would replace this with C. So that would just be a C. So every place I see a 0.8C, I would replace it with C right here. So that means that this term right here, this would be C plus 0.7C, which would have been 1.7C. And then down here, this would have been 1 plus UX, that's C, times 0.7C. That's just 0.7C squared divided by C squared, which is 0.7. Well, this is just 1.7 over 1.7C, which is just C. So even if she shoots out at C, Frank will still say it's C, right? And again, remember we said the speed of light is independent of the speed of the bulb. And so she could say that's like the light bulb right there. Okay, well, what happens if, let's look at another example. Suppose again, Mary is traveling this way at 0.7C. And instead of throwing it out the front, let's say she throws it out the back. She shoots a missile this way at 0.8C, right here. And we ask, how fast do we see it? We're just standing here. How fast do we see it? It looks like we're going to see it go this way because this speed looks bigger than that speed right there. Okay, so there's a couple of ways. I can see at least two ways we could have worked this thing out. We could have said, this is Mary. And we could have said V is equal to 0.7C. And then when we did her UX prime, we wouldn't have said 0.8C, we would have said negative 0.8C because she threw it out the back. So we could have said UX prime was equal to negative 0.8C. So that's one way we could have worked it out. Or, remember, relative to Mary, Frank is moving to the left. So we could have instead, said, this is Frank right here. Frank's on this thing. And he throws something to the right at 0.7C. 0.7C. So in this case, the speed of Frank would have been, V would have been 0.8C, because remember, Frank's going this way right here. And he would have said his UX, he's throwing it to the right, this would have been 0.7C. So we could have looked at it from two different perspectives. They both should give me the same answer. So maybe we'll just see if they both give me the same answer. And in this case, we want to find out what UX is. And on this one, we want to find out what UX prime is. Right here. It should give me the same answer. Just looking at it from two different perspectives. Well, let's just see what it is here. UX, now we're just going to come back to this equation right here. We got UX prime plus V. So it's this plus this. We're adding these two together, which is negative well, I think I'll write it all out and then we'll simplify it. If I add them up, we get negative 0.8C plus 0.7C all over, and remember down here, 1 plus, and then the product, 1 plus the product of these two, 0.7C times negative 0.8C all over C squared. This one down here, we would have used this first equation right here. We would have said UX minus V. So we would have said UX is 0.7C minus 0.8C all over. And then this one down here is 1 minus the product of the two, 0.8C times 0.7C all over C squared. Well, if you compare these, 0.7 minus 0.8 is minus 0.1, 0.7 minus 0.8 is minus 0.1. This is what that minus there will make this a minus 0.7, 0.8 over C squared, 1 minus 0.7, 0.8 over C squared. You can see they're the same right here. But let's get the value for it. if we get the value for it, this is negative 0.1 c all over 0.8. The c's drop out down here. 0.8, 0.7 is 0.56. 1 minus 0.56. Okay, and then 1 minus 0.56 is 0.44, so this is minus 1 over 0.44c, which ended up being, what did I end up with? 0.23c. 0.23c. And it's a negative right here. It's in this negative direction right here. So you could look at it either way, from either point of view. Well, let's look at another case. How about the case where you're throwing it perpendicular right here? Suppose that Mary doesn't throw it this way or that way, she throws it this way right here. So we have, you're going this way at 0.7c, and you throw something this way at 0.8c. What does Frank, well, it might be easiest to look at it from Mary's point of view because it's going to the right. So there's Mary, and Mary just throws something straight up. So we know that V is equal to 0.7c. We also know since Mary threw it straight up, ux prime is 0. She didn't give it any x component, she threw it straight in the y. So uy prime was equal to 0.8c. And we want to know, what does Frank see the speed as? That is, what is ux and what is uy right here. Okay, so now if we wanted to find ux, we'll come right back to here, plug it into there. So ux is equal to ux prime, which is 0, plus v, 0.7c, all over, the denominator is 1 plus this, which is just 1. So that's just 0.7c. Okay, and uy, we can plug in uy using this one right here. Plugging in uy, we get uy prime, which is 0.8c, times the square root of 1 minus v squared. V squared is 0.49 c squared over c squared, divided by 1 plus ux, but we already, uy, yeah, that's ux prime, sorry, that's everything prime is up. That's ux prime, which is 0, that was 0, so it's just 1 down here, 1. Okay, and so this is just 0.8c times the square root of 1 minus 0.49, which is 0.51, which ended up being 0.57c. 0.51. That's equal to 0.57c. Right there. Okay, so Frank says this is the x component, this is the y component. If I wanted to get the magnitude of the speed that I'm going to see it go at, because Frank's going to see it heading off in that direction, we just say u is equal to the square root, just like we did in 4a, ux squared plus uy squared, which is just this squared, square root of 0.7c squared plus 0.57c squared, which just ended up being 0.9c. 0.9c. Still less than the speed of light. Even if this would have been 99% the speed of light and that would have been 99% the speed of light, I still would never get this above the speed of light. I can never do that right there. Oh, okay, and if I wanted to get the angle that Frank sees it goes out at, we could have just said the tangent of whatever angle he sees it go at, let's just call it phi, would just be the opposite over adjacent, uy over ux. So it would just be this divided by this, which would be 0.57 divided by 0.7. Okay, and if you get that in degrees, it's actually 39 degrees. This is 39 degrees right there. Okay, well, there's when he threw it straight up. What if Mary throws it not straight up, but out at an angle? Right here. That's, I guess, the last one we could try. Let's say she shoots something out. Let's make it an easy angle. How about 45 degrees? And she shoots something out at 0.8c. She's going at 0.7c, but so she's going at 0.7c, and she shoots something out of 45 at 0.8c. And we want to know, how fast does Frank see it go at? Well, again, the velocity of Mary, this is Mary again, the v is 0.7c. Now we need to get what ux prime is. Well, ux prime is just the cosine part of this right here. So it's 0.8c times the cosine of 45, which is the square root of 2 over 2. And uy prime would be the same since it's 45 degrees, 0.8c times the square root of 2 over 2. Okay, and now we just need to go ahead and plug in and get ux and uy. Ux is, I always have to look at it, it's ux prime plus v, so it's this plus this, so it's 0.7c plus 0.8c square root of 2 over 2 divided by 1 plus the product of these, 0.7c, 0.8c square root of 2 over 2 divided by c squared. After a while, you probably will leave out all those c squares are always going to cancel right there. If you calculate this thing out right here, it becomes out to be 1.26 c divided by 1.39, which is 0.9c. Likewise, we can go ahead and get uy, plug it into the uy equation, which is uy prime, which is this one, 0.8c square root of 2 over 2, square root 1 minus this squared, which is 0.49, divided by, I think it's the same denominator. These two are the same denominator, so it's 1 plus, 0.7c, 0.8c square root of 2 over 2, all over c squared. So that's still 1.39. And the numerator on this one is 0.4. And so this was 0.29. 0.29 c. So Frank says that's your x component and that's your y component, and I get the magnitude of it. The magnitude of u would be the square root of ux squared plus uy squared, which is the square root of this squared plus this squared, 0.9 squared plus 0.29 squared. It's more than 0.9, but less than 1. If you ever get more than 1, you know you're making a mistake. So this is 0.95c. And we could have even got the angle too. The tangent of this angle relative to Frank, since you have a big velocity here, this angle is going to be smaller than 45. The tangent of theta is just, you just divide it. It's this divided by that. 0.29 all over 9, 0.9. C's drop out, and you get about 18 degrees. So this is 18 degrees. So we threw it in all possible directions right here. We threw it out the front, the back, the side, and an angle right here. So Now you know how to work out all of these problems right here with this velocity transformations. But you'll notice it's getting more complicated. And on the next one, we'll do the acceleration transformation. You notice things aren't getting nicer. They're getting messier right here. Okay.